name is Mikołaj. I work with livelihoods, and I will show you what Falcor is and how we use it in livelihoods. So my plan is, well, first some short introduction about data and APIs in general, then about Falcor, this will be the main part, and then as a bonus, one slide about how to integrate it with React, and also kind of a bit like how to structure large-scale application, because it's pretty much the same as the previous one. So first, introduction. So when you model the data, it seems pretty simple, usually. And there are some easy dependencies between your data entities. So I took this example from GitHub. This is how the GitHub API looks like. So this is some small part from the GitHub API. And in fact, when it looks like this, you would think that, well, it can be structured easily as, well, the user has repositories have issues, and so that it's all like one big tree, and we can just get, well, we could convert all this data to just one big JSON, and have the API like this, or maybe ask for some repo and just have all the issues. But the problem is that the data is in fact not really a tree, and it gets more and more complicated with many more dependencies. So, well, I just noted some that came to my mind, and I found it in the API documentation, but I'm sure that there are many more. And the data structure as such is usually not a tree, it's a graph. So it means that JSON is usually not enough, because JSON is a tree and our data is a graph. So we kind of need to transfer this. And there are kind of two ends of the spectrum when you develop APIs. So you could either go towards clean REST APIs, which have small endpoints, and where each endpoint returns a small piece of data, and you have a lot of those endpoints. Or you can have RPC, kind of. RPC means remote procedural call. So you could have RPC endpoints where they are big, complex, you can query them with lots of parameters, and they can give you anything you want, and possibly quite large amounts of data. So those are kind of like two ends of the spectrum. From my experience is that usually people start with some clean REST API, and then over time it turns into some big, complex RPC monster. But anyway, so REST APIs are simple, generally clean. RPC APIs are often complex. REST APIs have forced round trips, which means when I ask for some piece of data, usually I don't get the related data. And if I do, then I get just some amount of this related data, and then I get the answer back, and then I have to send one more request to get some other piece of data back. And this seems, well, unavoidable in large applications. So that, well, example that I had just today, that when in livelihoods, when we show a mobile book page, we want to show other books by the same author. So I query the book, then I get an answer. Then I query for the author of this book, then I get an answer. And then I query for all books by the same author, and then I get an answer. And then I can display the first cover of this book. And when I do it over the internet, it's slow. And RPC seems to have more flexibility and better performance in this aspect. So in REST it's also usually easy to control what data is fetched, because I just send more or less requests, and those requests are small. RPC, on the other hand, seems to solve it in another way, in some flexibility of endpoints. But in fact, well, there are some disadvantages in either of those approaches, and we want actually both. we want both to access our data in a granular way, and we want good performance. So Falcor tries to combine those two. So now I continue to the Falcor part. So, well, Falcor is something that kind of goes in. So, well, this is kind of your existing structure. So you have some front end, you have some back end. and this is connected. Well, when your users look at the front end, they think that it's in the cloud. So, in fact, it's in your server. And on your server, you have several services, and then you might possibly connect them in some kind of REST API, and then your front end or mobile app or anything could query this REST API. And as I said, well, REST or any other APIs usually suffer from one of those two problems. And Falcor is a proxy that fits in the middle and tries to solve those problems, so that you can still have small, maintainable, clean endpoints, and at the same time maintain good performance. Because all those round trips, they don't happen there in the cloud, let's say. They happen on your own server. So those round trips can be very, very fast. And then your front end needs to send just one request to Falcor, and then Falcor makes a lot of those small local requests to your REST API, and then sends back a big response to you, so that your page or your mobile app or anything can have anything you want, anything you need from all your backend services in just one JSON. So that's how it solves the problem of round trips and of poor performance and also maintainability. So the ideas are, so this seems like a big idea to imagine that we have all the cloud on our device, but in fact, this is what we try to tell our clients, kind of. Well, think about Google Docs. So you open Google Docs, and it looks like you have a folder, and you have some files in there, and you have a feeling that it actually all happens on your computer, but it's somewhere well away there in the cloud. And the idea behind Falcor is, well, let's imagine that we actually have it on our device. So let's just not try to tell the story to our user, but let's also write our code in this way. So let's not work with network requests to our API, and well, let's not worry about round trips anymore. Let's just talk about objects and their data, just like an ORM, providing access to the database. And let's also try to unify all of our data sources, so that we don't care anymore if the data is coming from the database or from Elasticsearch or maybe from some recommendations engine based on a Hadoop cluster or whatever. It's just in one place, so that when we fetch a book, then we can have a rating in one place, and well, some search suggestions and anything, we can have it in one place, in one data entity. And we can also have functions to change this data in one place. And also, when building APIs, there is also usually a problem with caching. So that when you build a REST API, you usually see the promise that, well, if you have some small endpoints that are easy to control, then also HTTP caching will work great, because whenever you ask for that user again, it would not actually make the request, because it will come from the browser cache, so it will not make the actual request. But in practice, the HTTP cache is pretty hard to control. And when you need to invalidate data, then you have to work around these mechanisms and add some query parameters, well, artificial, in fact, query parameters, and you have to maintain it. And you cannot access the cache directly, so you never know what's in the cache and what's not. And so it seems that it's better to have a clear and controllable caching mechanism, and that it's handled by a library. So in this case, it's Falcor that controls the cache as well. So I'm going to show some piece of code. So, well, the thing at the top is just a list of fields, so it's not interesting. The interesting thing is Falcor model.get. So, well, we of course need to initialize the Falcor model and tell it to use some HTTP data source, but then the usage of Falcor looks pretty much like this. So that to display a book page for our case, for our new mobile frontend, I asked for all the data for works. So I asked for the main work fields, which are here, and I asked for short quotes within some range, and for some fields from the short quotes, and some fields from the user who wrote the short quotes, and then I asked for reviews, and for each review some data, and for each review I want the first entry, and I want full text of it, and the user who wrote it, and I want to know the genre, and I want to have some suggestions from the genre, and I want to, I want more books from the same author, and so on and so forth. And so this is the big request that I sent to Falcor. And then in the backend, Falcor resolves those references. So in fact, when I ask for work ID review, the review is in fact not there. The review is kind of in another castle. So it's a reference. And then there is another path and another endpoint to get it from there. Just Falcor resolves those dependencies in the backend. So when they see you see the console log on the bottom. So this is what comes out from this console log. So this is just a data object, just like ordinary JavaScript object, and everything that I asked for is already here. So like reviews are already here. So with the first entry and all the data that I asked for, just like normal JavaScript object. But it's interesting. How does this magic happen? So let's look in the network tab. In the network tab, you see that there's a big request made the Falcor backend that just lists all those needed data points. So here it's URL escape, so it looks ugly, but you get the idea. And then when we look at the response, it looks similar, but take a look at this. We asked just for works with some ID and for some fields for it, and kind of everything was in the work. But the JSON that we got from the server is a different structure. It says JSON graph on top, and then it says, and then we have kind of other kinds of entities. So authors, a name, entries, genres, topics, users, works. So what happened is that what we get in this JSON from the server is the internal JSON graph structure, so that we see that this is the work Rasmus book. So we ask for this work, and we see that the genre, for example, is a reference. So this thing is a reference, and it points to genres and Romani in there. So then we will go to genres and to Romani, and here's our data. And the Falcor client puts it all together so that we can see this as just one big JavaScript object, and then we can easily pass it to our React components or Angular components or whatever other components you might have. And also notice that there's just one request to the model, so that I make just one request to the API for the whole page. And I will go into a bit of detail into how this JSON graph works. So JSON graph, so as you know, as you have seen, it's kind of like JSON, but it has references. And references look like this. So there's a value which tells Falcor where to go and where to get this piece of data. And there are atoms. And atoms can be any primitive values from JavaScript that just like you're used to. You can also wrap those values explicitly in an atom. And so this might not seem very reasonable, but using this notation you can add more information. And this is a great way to control, for example, those caching mechanisms, or to return some metadata together with the data. And so, for example, we can say that this data is some value, but it will expire, and if the user needs the data later, then please send a request for it again. So this is hard to achieve with normal REST APIs. And also using atom, when we wrap it, we can return many arrays of objects as one thing. So that for Falcor it is like a primitive, so it always returns as a whole, as one whole. Because when you have objects, you always query them by fields. So you never, well, unless you pack it as an atom, you never fetch object as one big thing. Just you fetch some specific fields of the object and never the object as a whole. And also very useful thing, the third type of stuff in the JSON graph is error. And this is important because in REST API, well, the request can succeed or a request can fail. And here, when we send just one big request to the API, we don't want this request to fail. It never happens. And it can happen that some pieces, that just fetching some pieces of data fail because the database is overloaded, or some other endpoint is down, or there is some bug or anything. So we don't want the whole page to fail. We just want some part of the page to fail. So that's why when there is some error in the route handler, Falcor returns an error like this and doesn't fail the entire request. So that's it about Falcor for now. I have just one slide about the React integration. So React integration is easy when you have a good component structure. So this pretty much aligns up with the previous talk by Christian. And well, so you have some components. You have some components composed of other components, and the key to make them easily maintainable and easily compatible with Falcor is to keep them stateless. And then, so the Falcor library gives us a Falcor server and the Falcor client, and to connect them. I personally think that the best idea is to have some container component that would load the data so that not every component talks with the Falcor client. So it's entirely possible, but from my own experience with Falcor, it seems that the best way is to have this logic separated in some container component, and so that this component only loads the data and it manages the data. It acts as a controller and it doesn't have any styles. It just it instantiates some other component, and those components in the bottom, they have styles, they look nice, and so and in fact, I think I did it with React. I think it's nice with React, but in fact you can use this structure and connect it to any other framework that you use, and it should just work, because Falcor is pretty much framework agnostic when it comes to the view. It's just for data fetching, data sending, and managing this data and managing changes in the data. So that you always know that you have one copy of the data, that the data is always consistent, that whenever you change anything, you have it changed in all the places. So in fact it's one place, but you can see it in many places on the page. So this makes it much easier to manage all this data together in a web application. So that's it. That's almost last slide, because I have two more. I'm finished about Falcor. I prepared a slide for you with some further reading if you want to know more about Falcor. Those slides are available on the internet, and then when you open them on your laptop or anything, you can click those links actually. So I'll give you some time to photograph the slide. And I have one more announcement. So as you know, I'm